Question number 2. The mass of the Mars is 6.39 into 10 to the power 23 kg. This is the mass of the Mars. And Jupiter is 1.89. This is 1.89 into 10 to the power 27 kg. Distance between both of them is 7.49 into 10 to the power 5 meters. Now you have to find the force exerted by the Jupiter on the Mars. Right? Why Jupiter on the Mars? Because Jupiter is having the greater mass. Okay. So, and the value of G is given here 6.7 into 10 to the power minus 11 Newton meter square per kg square. Okay. So the two bodies, the mass of the two bodies is already given here. Right. Okay. So very first write down what is given. Given is mass of Mars, suppose mm. This is 6.39 into 10 to the power 23 kg. Right? Always write what is given to you. Okay? While whenever you are solving the numericals. Now, the mass of Jupiter is also given. Suppose it is mj and it is 1.89 into 10 to the power 27 kg. Okay? These are the masses of the two objects. Now, the distance is also given. Distance between Mars and Jupiter. It is given as, that is d, right? This is what? This is d. D is equal to 7.49 into 10 to the power 5 meters. Right? Gravitational constant. Gravitational constant value is also given. G is 6.7 into 10 to the power minus 11 Newton meter square per kg square. Okay. Now we have to find the force exerted by the Jupiter on the Mars. So write down the force exerted by the Jupiter on the Mars is, according to the universal law of gravitation, F is equal to G m1 m2. So here your m1 is mass of the Mars into m2 is the mass of the Jupiter, mj, upon the distance between them, d square. Right? Okay. Now put the values. F is equal to G. G is 6.7 into 10 to the power minus 11 into mm is 6.39 into 10 to the power 23. mj is 1.89 into 10 to the power 27 upon 7.49 into 10 to the power 5 whole square. Right? So now you have to solve this to find out the answer. Right? So very first, this exponential term, separate them. Okay? And solve them. Getting that. And the decimal numbers, you can separate them. Right? Like 6.7 we have, 6.39 we have, and 1.89. So you can multiply these together. 7.49 square. Right? Now, in numerator, you have 10 to the power minus 11 into 10 to the power 23 into 10 to the power 27, right? In denominator, you have 10 to the power 5 square, right? So I'm just telling you how to solve it. Everybody please write down. Now, so first we can calculate this, right? Okay. So you can multiply these 6.7, 6.39 and 1.8. So this is around 80.91. Okay. And the square of 7.49 is around 56.1, right? Into Now solve this 10 to the power minus 11, 23 and 27, right? So it will become 10 to the power minus 11 plus 23 plus 27 upon 10 to the power 10, right? So this is equal to now 80.91 divided by 56.1. Then divide this. This is around 1.44. Okay. And here you have 10 to the power 23 plus 27 is 50, right? 50 minus 11 is 39, right? Okay. 10 to the power 39 divided by 10 to the power 10. Okay. So this will become 1.44 into 10 to the power 29. 39 minus 10 is 29 Newton. So what is the force coming now? So force of attraction exerted by the Jupiter on the Mars is 1.44 into 10 to the power 29 newtons. Is that clear? Okay. And this is your answer. Right? So the force exerted by the Jupiter on the Mars can be calculated by the universal law of gravitation, which is F is equal to G m1 m2 upon d square. Right? So you have to use this formula in this way. Everybody getting this? Yes, sir. Now put the heading free fall. What is free fall? When any object falls towards the earth under the influence of earth's gravitational force alone, then these are called free falling objects. And we call this motion as free fall. Okay, so when any object is falling towards the object because of the earth's gravity, earth's gravitational force alone, then we call it as free fall. That motion is called free fall. Is that clear? So please write down. Okay, so when we drop a stone from a height, right, so you can see that it is attracted towards the earth. Okay, and it touches the ground after some time, right? This is because of the influence of earth gravity, and this motion is called free fall, right? Now what is acceleration due to gravity? Put a subheading into this. Acceleration due to gravity. The symbol which is used for this is G. Okay, small g. Acceleration due to gravity. Right? So whenever an object falls towards the earth and acceleration is involved, you can see that its speed is increasing as it is, going, nearer to the surface of the earth. Right? So this acceleration is due to the earth's gravitational pull, because there is a force which is exerted by the earth on that object. And whenever there is a force exerted on the object, there is an acceleration. Its speed will change, right? So when you have dropped it, its speed is zero. Its velocity was zero. But as soon as it is falling down, right, and come closer and closer to the ground, its speed increases, right? So from where this speed, where this increase is actually occurring because of the force which is exerted by the earth, right? The gravitational force, the gravitational pull of the earth, and this acceleration, this change in speed of the free fall object is called acceleration due to gravity, and it is denoted by small g. Everybody getting it, right? So many times you have dropped something, right, from some height, right? So you can see easily that when you are dropping something, its speed is initially zero when you have just dropped it, right? But as soon as it is going closer to the earth, its speed increases, right? So this increase in the speed is the acceleration. Is that clear? And from where this acceleration comes? from the gravitational
Gravity.
pull of the Earth, right? Because of the gravitational force of the Earth, because it is attracting every object towards it, towards its center. Everybody getting this? Yes or no? Okay, so this is acceleration due to gravity denoted by g. Now, what is the SI unit of the g? Since it is an acceleration, the unit of g, SI unit of the g is same as that of the acceleration, a, right? V is equal to u plus at, right? So you have already learned that a is equal to v minus u upon t. So what is the unit of acceleration? Can anybody tell?
Meter per second square.
Meter per second square, right? So same is the unit for g, right? So SI unit of g is meter per second square. Okay. So now suppose mass of Earth be m, right? So we are just finding out the relation between g, small g and capital G, right? So you have seen like one more g earlier, right? That is the gravitational constant, capital G, and this was acceleration due to gravity. Now let's see what is the relation between this g and g. Okay. So let mass of Earth is suppose m. Okay. And the object falling freely towards it, the mass of it is suppose small m. Mass of freely falling object is suppose small m. Okay. Now distance. What is the distance between them? Between the Earth and that object? It will be taken as again the radius of the Earth, right? So distance between the centers of Earth and the object will be taken as r. That is the radius of the Earth, right? Because from whatever height it is dropped on the surface of the Earth, it is negligible in comparison to the radius of the Earth, right? So that's why we have taken it equal to radius. So radius of Earth, right? Now from Newton's law of gravitation, which we have already learned in the previous topic, from Newton's law of gravitation, we know that F is equal to G m1 m2 upon r square, right? So here your m1 m2 is capital M and small m, right? So I have written here this upon r square. So this is from the Newton's law of gravitation. Suppose this is your equation number 1. Okay. Now from the second law of motion, everybody know what is the Newton's second law of motion? From second law of motion, force is given as mass into acceleration, m into a. Yes or no? This is the second law of motion. Suppose this is, okay, not this. Okay, F is equal to m into a. Now, since here your acceleration is what? Our acceleration is g, right? That is acceleration due to gravity. Because whenever there is a free fall, our acceleration is g, right? So instead of a, we will write it as m into g, right? Okay. So here your acceleration is g. So F is equal to mg, and this is now suppose your second equation, right? Now, this is your force, F is equal to g m upon r square, and this is also force, right? Can we equate them, right? Both of them. So from 1 and 2, what we can write? That mg is equal to g m upon r square, right? So we have equated both because both are equal to F, right? So now m will cancel. So what will be having now? G is equal to, small g is equal to capital G m upon r square. Is that clear? And this is the relation between small g and capital G. right? So now from this formula, it is clear that acceleration due to gravity, G, does not depend on the mass of the freely falling object, right? Because there is no term of m. It is cut it, right? We have cut that. It is cancelled. Are you getting that? So from this equation, we can say that acceleration due to gravity does not depend on the mass of the falling object. Is that clear? It depends only on the mass of Earth. Okay, you getting that, right? Or you can say the celestial body, right? So if you are on Earth, then the acceleration due to gravity will depend upon the mass of the Earth. If suppose you are on any other celestial body, right, in the space, then its acceleration due to gravity will depend upon its mass, not the freely falling object. Everybody getting this? So write down from this formula. It is clear that G does not depend on mass of falling object, right? Okay, it depends upon mass of the Earth only. Is that clear? Okay, so as the distance of an object from the center of the celestial body increases, the value of G decreases, right? So if we increase the distance of the object from the center of the Earth, G start decreasing. Okay, and at the poles, if we talk about the poles, Earth is flattened at the poles. Okay, on both the poles, it is flat, right? So therefore, radius of Earth is less at poles, right? Because it is flat. It is not completely circle, right? It is getting that Earth. The shape of the Earth is not a complete circle, right? It is not round at the poles. It is flattened at the poles, right? And there's a reason the radius of Earth is less at poles than the equator, and hence the value of G is less at equator than the poles. Okay, right? Because G is inversely proportional to R square. So there R is less. Therefore, G is okay. Is equator, it is less. Am I getting that? Okay. So please write down. Okay. Now, how to calculate the value of G, acceleration due to gravity? So put the heading, calculation of the value of G. Right. So as we have already seen that G, small g, acceleration due to gravity is equal to G, gravitational constant, M, mass of the Earth, and R, radius of the Earth. And all these quantities we know, the value of G also we know, mass of Earth is known to us, R is also, radius of the Earth we also know, right? So by putting the values, we can easily find the value of the G, small g, that is acceleration due to gravity. So let's do that. Now, G is equals to Gm upon R square. We have already seen this. Okay. Now, as we know that mass of Earth, that is M, is 6 into 10 to the power 24 kg. Radius of Earth, that is R, 6.4 into 10 to the power 6 meters. And the value of G, universal gravitational constant. Its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square, right? So now we know the values of all the three. So we can put these value now to find out the value of G. So this is Gm upon R squared. So this is equal to 6.67 into 10 to the power minus 11 into M. M is 6 into 10 to the power 24 upon R. R is 6.4 into 10 to the power 6 whole square. Now we will calculate this, right? So in the same way, you have to calculate as I told you earlier. So after calculating, you will find the value of G is 9.8 meter per second square. Okay, so please calculate it. Okay, you will get it. So this is the value of G, that is 9.8 meter per second square, right? So this is the acceleration due to gravity of Earth. Okay, so in questions, we use this value of G, that is 9.8 meters per second square, and sometimes we use its approximate value, that is 10, if it is given in the question, right? Okay, so generally, it is not given in the question. If it is given, then fine. If it is not given, then you should know this value, that G is 9.8 meter per second square, right? So the values of all these terms, right? Okay, whether it is capital G, small g, you should know. Please learn them. Okay. Now, everybody noted till here, please tell. Now, let's see what are the equation of motion for free fall. As we already know that there are three equations of motion which you have seen in your chapter number 1, right? Equations of motion, right? And we have already derived them, right, in that chapter for the bodies under uniform acceleration, right? Now, in the case of motion of bodies under the free fall, there is a uniform acceleration, and that acceleration is acceleration due to gravity, G, acting in the downward direction, right? So the previous equations which you have learned, equation of motion, they can be applied for the motion of bodies under the free fall. Okay, so let's see how of motion. So the general equations of motions which we have already studied, general equation of motions. And equations for body under free fall. Okay. Okay. So the first equation of motion, general equation of motion is V is equals to U plus AT, right? Now, the first equation of motion for body which is under free fall will be now V is equal to U plus, instead of A, we will write G. Getting that? Okay. Because now when the body is freely falling, the acceleration is acceleration due to gravity, that is G. So A will be replaced by G. Is that clear? Okay. Why we have done this? Because A is equal to G here. Getting that? Everybody understood? Then the second equation of motion S is equal to ut plus half at square. This is your second equation. So now here it will be h instead of s, the distance. Here we have height, because when the body is freely falling, right? It is falling from some height, right? Height above the ground, right? So instead of s, we will replace it with h. H is equal to ut plus half. Now instead of a, we will write g, gt square. Okay, is it clear? Then third equation of motion is v square is equals to u square plus 2as. Now here it will become v square final velocity, u square initial velocity plus 2as. यहाँ पर as था तो a की जगह g हो जाएगा और s की जगह h हो जाएगा, 2gh. Is that clear? So equation of motion, the third equation of motion for the body under free fall will be v square is equal to u square plus 2gh, right? Where g is the acceleration due to gravity and h is the height. Okay, so write down. Where h is height from which object is falling. Object falls. Okay. T is the time of fall, how much time it is taking to touch the ground. Okay, that is T. U is the initial velocity. Initial velocity. Are you getting that? Okay. So what will be the initial velocity when a body is freely falling? From some height, it is always zero, right? V is the final velocity. Okay, final velocity. And G is the acceleration due to gravity. Okay, is that clear? Now, while solving the numericals, we should remember some points about this, right? Important points. To remember while solving numericals. Okay, what is that? If an object falls vertically downwards, then acceleration due to gravity is taken as positive. Okay, why? Because its velocity increases while falling. Okay, so if object falls vertically downwards, okay, G is taken as positive. Okay, because its velocity increases. So acceleration will be positive. Now, if an object is thrown vertically upwards, if we are throwing some object in the upward direction, then for this, the acceleration due to gravity is taken as negative. Okay, we take it as negative because we are moving, oh, sorry, we are throwing that object, right, upwards, and its velocity will decrease. So we will throw an object with some initial velocity, right? And its velocity will decrease, right? Because a force, which is the force of attraction applied by the earth, is working in the downward direction and it is moving upwards, right? So that's the reason its velocity decreases, right? Is that clear? Now, when the object is falling vertically downwards, as we know that G is taken as positive, U will be 0, okay? When the object is thrown vertically upward, G will be taken as negative and V will be 0. Final velocity will become 0 after a certain height, okay? And if it is falling from some height, then initial velocity will be 0. If you're throwing any object in the upward direction, then its final velocity will be 0. Is that clear? So let's see like how to solve the question using uh, these equations of motion, right? In the case of free fall, right? So just look at this question number 3. A car falls off a ledge and drops to the ground in 0.6 seconds. Okay, right? Now, The value of g is 10 meter per second square, which is taken so to simplify the calculation. Now you have to find what is the speed on striking the ground. Means when this car touches the ground, right? What was the speed of it? What is the average speed during 0.6 second? You have to find the average speed. And how high is the ledge from the ground, right? What is the height of the ledge, right? Okay. And what is the meaning of the ledge? Basically, it is a horizontal surface, uh, or we can say cliff, right? A horizontal surface projecting from a wall, right? Okay. So this car is falling from some height, right? And time taken to touch the ground is 0.6 second, right? So very first, write down what is given to you. So whenever you are solving a question, first write down what is given in the question. Okay. So now given is what is u? Can you tell me what is u? Initial velocity. What is u for car? Tell me first. So u is 0, right? Now what is g? Value of g, acceleration due to gravity. It is given here. So since it is given, we will take this value. Otherwise, we will take 9.8. So here it is given 10 meter per second square. So we will use this. So g is 10 meter per second square. Now time taken by the car to touch the ground, that is t, is given 0.6 seconds. Means in 0.6 seconds, it dropped, right, on the surface of the earth, right? Now what we have to find in the first part, we have to find the speed on by which it is actually touching the ground, right? On striking the ground, what was the speed of the car, right? Means you have to find the final velocity, right? Okay. We have to find speed. That is v. You have to find, right? So we know that according to first equation of motion of free fall, v is equal to u plus gt. Instead of a, we will write g here, right? U plus at. So now since it is a free fall, we will write v is equal to u plus gt, right? Now since we know every quantity here, so we simply write down the values. U is 0 plus g कितना है 10 है, so just write down 10 into time. Time is 0.6 seconds. Please remember, whenever you are putting the values in the formula, please check their SI units. If they are not in their SI units, first convert it and then write the values. So now v will be 6 meter per second. So what will be the velocity of the car when it hit the ground? Final velocity of the car?
Second.
That is 6 meter per second, right? So what we have done, we are using equation of motion to find this, okay, right? And taking the consideration that this is a free fall, right? Now, second part of the question. Here we have to find average speed during this 0.6 second, right? So why we are finding average speed here? Always remember, whenever there is a uniform acceleration motion, right? Free fall is also a uniform acceleration motion. Means acceleration is uniform, but speed is not uniform, right? Speed is changing. That's the reason we have some acceleration. तो acceleration जब ही होगा जब speed change हो रही होगी. अगर speed change नहीं हो रही तो acceleration 0 है, right? So since this is a uniform acceleration motion, speed is changing. ठीक है, हर एक point पे उसकी speed बढ़ रही है, right? Okay. Initially it was 0 and now as soon as it is coming right near to the surface, its velocity is increasing, right? और final velocity कितनी होगी 6 meter per second. ठीक है, 0 से start हुआ और जब वो touch किया ground से, when it hit the ground, its velocity was 6 meter per second. That means velocity is changing. Now since velocity is changing, we have to find the average speed. We need to find its average speed, right? So how you will find the average speed? What is the formula of finding the average speed? Can anybody tell? Formula to find average speed. Okay, so average speed is, formula for finding average speed is total distance upon total time. Total distance upon total time. Here we know the total time taken by the car, right? That is 0.6 second, but we don't know the total distance, right here. Okay. So first we will find out the total distance. So we have to find the third part first. Okay. How high the ledge from the ground means we have to find the height of the ledge from where the car is falling, right? So find out it. Distance traveled by the car. Distance traveled means height of the ledge. This is, we can find it by the second equation of motion, that is h is equal to ut plus half gt square. This is your second equation of motion, right?
Yes, ma'am.
Okay, now u, t, u is 0, so u into t will be 0, plus half, value of g is 10 into t 0.6, right? So in this way we can find the height from where it is dropping, right? Okay, so this will be equal to 5 into 0.36, 0.6 square is 0.36, multiply, this will be around 1.80 meters, right? So what is the height of the ledge? 1.80 meters. This is the height of the ledge from where it starts falling, right? So this is the distance traveled by the car, right? From the point from where it is falling till ground, right? Now we can use this height here, total distance traveled. That is 1.8 upon total time is 1.6 seconds, right? So this is 3 meter per second. So what is the average speed of the car? V average speed of the car is 3 meter per second, right? Okay. So in this way, we can find our average speed, distance traveled by the car, and the velocity of the car when it hits the ground. Is that clear? So same approach you have to follow whenever you are solving the question of free fall. Okay. We can find average speed by adding u and v and divide by 2, but this will give you approximate value. Sometimes you will get the exact value also, but if you are asked like what will be the average speed and there are multiple speeds, right? Please find out the total distance as you have done in your motion chapter and then divide with total time to find the average speed. Okay. Any doubt in this question, please ask.
No, ma'am.
Okay. So look at this question number 4. A ball is thrown vertically upwards with a velocity of 25 meter per second, right? So we are throwing a ball vertically upward with some velocity, right? And the initial velocity with which we are throwing it is 25 meter per second. G is taken as 10 meter per second squared. Now you have to calculate the height it reaches, the maximum height it will reach and then come back, right? And the time taken to return back. So you have to find h and t this time. Understood? Right? So what we have to do now first, the very first step while solving the question. First write down what is given. So what is given? Initial velocity is given or not? What is it? Initial velocity of the ball, that is u. What is initial velocity here? What is the initial velocity here?
25 meter per second.
25 meter per second because it is thrown upward with this velocity, right? So now this time, because this motion is against gravity, right? So we have to give some speed, right? Then only it will go in the upward direction. So u is 25 meter per second. Now, what will be the final velocity in this case? Final velocity of the ball. What will be the final velocity of the ball? Rudra, can you tell me? What will be the final velocity of the ball? V is, final velocity is 0 meter per second. It is 0. Okay. Now, since the body is thrown upwards, At the highest point, velocity will be 0 and acceleration due to gravity will be taken as negative. Is that clear? So g will be taken as minus 10 meter per second square.
Ma'am, so
Why?
the answer will also be negative, right?
Wait,
For the height.
no, I will tell you. Acceleration due to gravity, right? G will be taken as minus 10 meter per second square. Now look at the first part. We have to find the height, right? Height means if we are throwing upward a ball, right? So it is going upward, right? Right? Initially, its velocity is 25 meter per second. Now, after reaching a particular height, its velocity will be 0, right? Okay, at some height. Now, from this point, it will come back to the ground, right? Is it clear? Okay, and hit the ground again, right? So we have to find this h. Is it clear? Okay. Now, according to the equation of motion, the third equation of motion, remember, what is that? Third equation of motion for free fall, V is equal to U square plus 2GH. ठीक है? सेकेंड वाली इक्वेशन क्यों नहीं यूज करेंगे? क्योंकि हमें टाइम नहीं पता, राइट? एंड देयर इज अ फैक्टर ऑफ टाइम, राइट? देयर इज टी. h is equal to ut plus half gt square, but we don't know t, right? So that's why there are two variables in that equation, t and h, right? So we cannot use that one. So we will use the third equation of motion, v square is equal to u square plus 2gh. Here we know v, u and g, and h can be found out. Is that clear? So now put the values. V will be 0. U, what will be the initial velocity? What is the initial velocity? 25. 25 square plus 2 into 10. 10 will be taken as negative, minus 10 because acceleration due to gravity will be taken as negative here, into h. H we have to find. Right? So h will be equal to 0 minus 25 square upon 2 into minus 10. Right? Getting this? Now solve it. Minus 25 square, 625, upon 2 into minus 10 is minus 20. Minus minus sign will cut. And divide 625 with 20, you will get the height 31.25 meters. So you will find that automatically your negative sign will cut, right? Height, length can never be negative. Okay. So if you are getting negative answer, that means you have done something wrong. Okay. अगर आपका negative value आ रहा है, इसका मतलब आपने कुछ गलत किया है. Just check it out. Okay. Right. So you can see here that h we have found out 31.25. Right. So what maximum height it attains? 31.25 meter. Right. तो इतनी हाइट तक बॉल जाएगी और उसके बाद क्या होगा? वापस आएगी नीचे. ठीक है? Just relate it with this practical scenario, right? As you do while playing, right? While playing cricket, you throw that cricket ball, yes, many times, isn't it? So just relate it. So it is very easy to understand physics if you relate it with the practical things, right? Practical phenomena, right? Okay. Second part of the question, time. We have to find out time. Now, we know the first equation of motion, V is equals to U plus GT. Now we know V, U, G we already know, we can find T. So T will be equal to V minus U upon G. Right? Now put the values. Final velocity is 0. Initial velocity 25 upon G, which is 10. Getting it? Minus 10, not 10. Now time will be equal to 25 by 10. Minus minus will cancel. And this will be equal to 2.5 seconds. Right? So time taken by it to reach the maximum height is 2.5 seconds. Right? But we have to find the time to return back. Are you getting it? Right? So it is taking some time here to go from this position, from position A to B, right? Okay, this is your T, which is 2.5 seconds. This is the time taken to return back. But always remember, total time is always equal to time of ascent plus time of descent, right? When it is going up and going down, right? It is a sum of the two. Getting it? And what will be the total time now? Total time will be, and they are equal, right? Always remember, time of ascent and time of descent is always equal, right? So total time will be 2 into 2.5 second, that is 5 seconds. So this is the total time taken by the ball to return back, right? That is 5 seconds, right? So if it is taking 2.5 to go up, then it will take same time to go down, 2.5 seconds. Is that clear? So we always multiply it by 2, right? So time of ascent and time of descent are same. Is that clear? So this is how we can find out the time.
Ma'am, what is